Session now will be given by Mr. K.P. Manoharan of GemOrion Machinery Pvt Ltd. The topic is focus on energy efficiency in industrial cooling. Mr. K.P. Manoharan is basically a Coimbatorian. He did his BE Mechanical Engineering in Government College of Technology, Coimbatore in 1977 to 82. He is a recipient of the Best Project Award from Madras University for jointly fabricating CNC-based PCB drilling machine in 1982. He joined ME Industrial Engineering in Pvt Tech and worked there between 1982 and 84. He planned the complete layout change for the pump assembly at PGC Industrial Institute at that time, and it was a great success to enhance productivity. Between 84 and 86, he manufactured wet grinders and machined components as job work. In 87, started manufacturing compressed air dryers and cooling towers. Between 89 and 90, he had the opportunity to enter into two-wheeler sales of Hero Honda dealership in Coimbatore, still running as Gem Motors. In 1993, they started developing waterless dry cooler concept in India and saved millions and millions of liters of water by elimination of evaporation losses in cooling towers. Even today, this is being supplied to Cummins, GE, etc. for the diesel and gas engine products. GemOrion Machinery Pvt Ltd makes inverter precision chillers with highest energy saving capability, which are very unique to the Indian market, with no equivalent product available for precision cooling anywhere in India for process cooling applications. Let us have Mr. Manoharan to deliver the lecture.
Good evening to all of you. Sir sonnaru that I have done a lot of work for water conservation. Last 15 to 20 years I am working on, today people are talking about sustainability. Sustainability means not only energy saving, also water saving. So water also is considered to be a very scarce resource. Normally people consider water as free. So far, maybe slowly that concept is changing, but there is lot of pressure from the government side, maybe even from social side. The water availability and in some places water may be available, but problem is today we are looking at cost conscious manufacturing. So when we are looking at sustained productivity without breakdown, making it at lowest cost, the water quality plays a very major role. If you have a water quality problem, water may be available but water quality is a problem, then your system suffers. And normally this water is used for cooling lot of typical applications. And in plastics, because we are plasticizing the material at high temperature and trying to mold it, until and unless we cool it to the ideal temperature for removing the molded component, we may not be able to get the faster cycle time, and ultimately that is the efficiency. So cooling towers were very widely being used for the cooling, mold cooling and power pack cooling in the hydraulic machines. Water cooling tower was being used. Even today people are still continuing to use cooling tower for cooling the mold as well as for the cooling for very crude applications. But today when we are looking at improving the process cycle time and productivity and quality of the component, mold the molds have become expensive. To keep the mold's life, to enhance the mold life, we have to cool with closed circuit water. That means once water is filled, it will be recirculating within the system so that we will not have any evaporation losses. So hence no scaling will happen. So I am going to talk about the energy efficiency in industrial cooling.
Front to back. Front.
So a small brief about our company. I am a first generation entrepreneur. We started the company with two other directors in 1984. And in 1987, we were one of the first to develop and manufacture compressed air dryers. And even today, we are the largest dryer manufacturer in India. We produce around 10,000 dryers a year. So this is one of the largest in Asia Pacific, except maybe China or Thailand. And 90s, we made the first cooling tower. In fact, in 1997, we were one of the very few companies to get ISO 9001. And in 2007, we initially tied up with Orion Machinery of Japan, which was a 70-year-old company that time. They were manufacturing chillers, so we entered into a collaboration, means franchisee tie-up with them, and we started giving services for them. And in 2017, we decided to start a joint venture company to manufacture chillers, precision chillers in India. And in 2020, so all the technology transfer was happening. So we were continuing to make our normal on-off chillers during that period. And in 2017, 2020, we launched our first inverter chillers. 2019, December was the time we launched our first inverter chillers. And in 21, we have supplied our chillers to a lot of challenging applications like PET preforms and laser cutting, huge 20 kilowatt, 25 kilowatt laser machines, thin walls and things like that. And recently we have supplied for MRI cooling also. So, and we have developed a full range for preform cooling application, inverter chillers. So basically a small brief about Orion. Orion was started in 1946 by OTA. They also make, the very funny situation, they also make all refrigeration dryers, clean air systems, vacuum systems. They have manufacturing plants in Japan, China, Taiwan, Hong Kong, Korea. They have assembly process in North America and now in India, with about 6,000 direct employees and 16,620 indirect employees. They also made one of the first milking equipment, so they are more into dairy and dairy milk application. That is the brief profile of Orion. Gem Equipments basically is a Indian company manufacturing cooling towers, and we were also making chillers with our 35 years of experience in process cooling. We have dry cooling experience. We are also a compressed air manufacturer, supplying to a lot of private and public sector. We also make modular cooling towers, and we also had a pan-India sale. So that means we were a complete solution provider with all cooling solutions. So some of our products, dryer, desiccant dryer, especially we had opportunity to supply a lot of such dryers during the period of COVID 2021-22 for all the hospitals. We supplied a lot of air dryers for oxygen plants. So some cooling tower products, FRP cooling tower, silent cooling towers, high temperature cooling towers, 90-degree cooling towers, modular cooling towers, dry cooling towers and adiabatic cooling towers, some of our products. And some of our Orion products, Japanese products are chillers up to modular construction, 30 TR. Then we have inverter GKE series. Then we have laser application chillers, small chillers, and we make for EDMs, chillers for EDM and for water soluble coolants. So basically it is a 50-50 joint venture between Gem Equipments and Orion, an Indo-Japanese joint venture company. World-class chillers are, the objective is to supply world-class chillers at Indian prices with excellent testing and Japanese process for brazing and other things. We are following the Japanese standard. Chillers are non-cyclic, so very high reliability. Then from day one, that is from 2017, we have started with R410A gas, which is a lesser ODP gas. Then water precision is from up to 0.1 degree accuracy can maintain. That means when water is set at a specific temperature, say you want to set at 15, irrespective of the varying load, the water temperature will be precisely maintained, the cooling water will be maintained at plus minus up 0.5 to 0.1 degree accuracy. Then normally the process chillers are set between 10 to 15, or maximum you can set it up to 20. But our chillers are designed to operate somewhere from about 7 degree or 10 degree to up to, it can work up to 30 degree. So even if you want to set 30 degree for some specific applications, requirements, season, above the wet bulb, above the dew point, so whatever, so you can even set it at about 30 degrees. So that is, all our standard chillers are capable of that. Then they are all having with the communication protocols, you can integrate, you can use 12 chillers in series, in parallelly you can operate. One machine can be a master, other can be slave, like that, so different options. Condensers are all fans for the precision control. We have inverter fans. This is our facility. So our assembly line, our brazing is all qualified by Japanese process. For tanks and other things we use robo welding. We have a complete testing setup, so we can test our chillers from about 5 degree ambient up to 50 degree ambient. We can test it in the chamber. So we have a full testing of chillers at full capacity. We can test. Certified capacity can be tested. So all chillers are tested and certified. So now coming to the cooling application for molds. So this is typically a cooling application for the mold, where we have to cool the mold as well as the during opening and closing, and for injection molding, we have to select the right equipment and right temperature for the cooling application. Selection of the cooling is completely dependent on the wet bulb temperature. So if you want a water temperature of anything below the wet bulb, you only have to use a refrigeration system. A conventional cooling tower cannot maintain the temperature below wet bulb temperature. So what is the customer's perspective or requirement for the chiller? Cooling system should not consume any water. Its power should be very, very low when compared to conventional on-off equipment. It should also help in high productivity by reducing the cycle time, and it should give consistent quality, because the temperature at which the mold is controlled by the water is at very accurate temperature. So obviously the product quality will be, the quality consistency is maintained, and lesser maintenance and downtime of the mother machine. So when you talk of the different types of cooling system, we have closed loop cooling and open loop cooling. So in open loop cooling, you have a normal cooling tower, wet cooling tower is the conventional process. In the closed loop, we have closed loop with water loss, we have systems. We have evaporative coil type, adiabatic type. We can use a cooling tower with a combination of heat exchanger. We can use a wet cooling tower system as a combination system with some automation. And you can also use wet, dry, as well as with adiabatic. You can combine and use a system where with minimum water loss, you can maintain the specific temperature. So these are with some losses. Parallelly, if you see, without loss means either you use dry cooler. Dry cooler is a typical radiator system it can maintain ambient plus 2-3 degree temperature consistently. With adiabatic addition, with small water, it can maintain lower temperature. Chiller, then you can have a chiller and dry cooler combination for achieving the required temperature of water. So typical cooling tower, I need not tell in very detail about the problems associated with cooling tower operation. Because of continuous evaporation, the hardness in the water continues to maintain in the water, and it scales and clogs the pipes, heat exchangers, molds, so that the temperature, the cooling efficiency is affected. And other than that, typically some water losses happen. It will be about 1% typically evaporation loss, and if your water quality is bad, you need to make up the water by blowdown. So obviously you need to add water, so that also adds to the water cost. And when you consider cost of water at 10 paise, 15 paise, 20 paise. People buy RO water, or some people use even DM water for some processes. These are the running cost per hour for the different capacity of cooling tower. So why? So the process water in closed loop and water loss. So evaporative coil cooling tower will have a tower with, you will have evaporation like a cooling tower, but your process and your cooling tower will be isolated. Adiabatic dry cooler will maintain zero water loss, but the disadvantage will be you will not able to get the required temperature to near ambient temperature, you cannot get. Then we can have a wet cooling tower and plate heat exchanger combination that can maintain the temperature. So when the ambient is lower in the night and in winter, it will run dry, and during the peak period, cooling tower can switch on, and by that way you can reduce the evaporation and water losses. Then we can have a wet and dry combination also. So this is the typical dry cooler process. So why people prefer a chiller for a complete overall solution is, the chiller is required for the mold cooling and for some application even for the oil cooling. But when you look at the water problem, water cost, water loss and other calculations, when you see, then chiller seems to be a very viable option, so that the single equipment takes care of the entire your requirement. So once it set at a specific temperature below ambient, and with the refrigeration system it maintains the temperature. It can be applicable for low temperature application, and consistently irrespective of the changing season, whether water, ambient goes up, comes down, you maintain the temperature, and you can maintain precise temperature, and without any water loss you are able to maintain. So that is the advantage of the chiller. So chillers are typically a 360, almost it gives an overall solution. So ideal solution for mold cooling, oil cooling, and MTCs also. Feed throat, MTC also it can maintain. So it maintains the set temperature of the mold. Oil temperature can be perfectly maintained, so you will not have any problem with your oil valves, or oil quality doesn't deteriorate. Similarly, in servo machines, the heat load is so low so that the chiller will take care of that requirement. And the trend is to use dedicated machines for dedicated chiller for dedicated. Maybe you can combine 2-3 machines and have one chiller, or maybe 1-to-1, so that it is possible to run the chiller at different temperature depending on the material requirement, depending on the process. You can maintain different temperatures for different machines cycles. Plus, the Orion chiller gives precise temperature of mold and oil cooler, and you can set any temperature from 7 degrees up to 30 degrees. So this typically shows the comparison between the temperature of application and the process control. So if you see the running cost, if you see on the left hand side, the compressor inverter control is the lowest power, and compressor on off control comes next. So between these two itself, there will be at least minimum 20 to 30% power difference between a simple on-off system and an inverter system, because there are two things. One is inverter control system is a IE5, it is a permanent magnet motor system, so it can on-off multiple times. Whereas a conventional on-off compressor, regular compressor available for refrigeration, these are not permanent magnet motors, so their efficiency is slightly lower than the inverter compressors. So basically the concept is, the world is moving towards energy savings and net zero. So that is our climate change. So energy efficiency is the world's first fuel, and the main route to get net zero is to go to a net zero. And energy saving, our chillers can save up to 60% power because of by adopting the zero loss of evaporation, the highest COP and least power, and other advantages I have already told. So this is the main advantage of the products: capacity, accuracy, energy saving. It can operate at 50 degree ambient, so you don't have to go for a water cooled system. You're not compelled to go for a water cooled system. Can maintain any temperature from 10 to 30 and very high energy efficiency. So this is a typical energy curve for the inverter unit. So at even 100% load, the actual power when compared to on-off equipment will be about 20%. As the load goes down or when your cycle varies, there is a lot of on-offs in your system. On-off means there is a cycle time, then the average load it takes, the average load comes lower and lower. And at very low load, because of the pump power, the power at 40% is almost 40%. So actually what it translates is, suppose if there is an equipment, what we have seen from customers in the last 2-3 years, supplied about more than 300 machines in the market. The customer's feedback is, even if he stops this old machine and buys a new machine, his payback is less than 2 years only in the energy saving. So like that, we have a lot of multiple customers have replaced their existing on-off chiller with the inverter chiller. Typical example is Livia Polymer in Trichy. Yes, they have already replaced, they had some 41 of our old on-off chillers, 15 and 20 TR, of which about 30 they have replaced in the last 2 years. So they are able to get the payback within 2 years. So that is the greatest advantage of these inverter chillers. This AV is a very standard model. It has been tested, validated with the tank, with VFD driven compressor and fan motor. And we have a hot tank model and a cold tank model. So AV is a hot cold tank. So depending on the process requirement, we can select. So we are experts in selecting based on your requirement. We can select what is the suitable model for you. Then we have a model without tank. So you can have an external tank. Suppose you have a multiple system operation with higher flow, lower flow, some differences. Then we can have an external tank. Without tank, the chiller can operate. Then we are also customizing the product. For example, for some process and other transformer cooling, some different applications, we are customizing the product also. So very low running cost for the product. The production cycle times can be higher, very high power saving capability, and very wide operating voltages. Then you can use 3 to 4 chillers in parallel, communicate with each other and run these chillers are capable of multiple operations, and very high on reliability because of the inverter operation. So some PET, we have supplied some, developed some series for the PET. So there we have, depending on the model, we can optimize the pump size, and the pump also can be a IE5 with a permanent magnet motor, inverter built-in pump, so that the power can be optimized. Then we have high pressure pump for specific mold application, then built-in VFD and pump. Then we also give it along with an energy meter, so that you are very clear on what your old machine's energy was and the new energy is. Then we have a remote communication, RS485 communication is there. Either you want to use it, you can use it, you can connect it to your mother machine, operate the mother machine, give warnings. So all those operations are built into all our standard chillers. And we can give customized pump units, and we are also offering some auxiliaries like filters, pH meters, we have conductivity meters, those also can be automized. So the advantages of going for this kind of a inverter chiller is not only power saving and precise control, we also can bring down the size of the stabilizer. So normally when for some precise applications like laser machines, machine manufacturers do recommend a stabilizer, so stabilizer capacity comes down. Then your emergency starting generator capacity also comes down, because the current is limited to only 100 full load current plus 10% only it goes, whereas if you go for star delta, it might go up to 6 times, normal DOL goes up to 8-10 times. You can go for servo stabilizer if you want, depending on the process reliability. Similarly, there is no complex piping, you can put it near the machine and run it, and it can be connected in modules. So some additional accessories, like you can have a remote operation, then flow and temperature sensors, conductivity meters and filters. So a single line can connect to both the mold as well as for the hydraulic system. Normally hydraulic system will have a solenoid valve control to maintain the oil temperature. If it is not there, we can fit it with a thermal valve. So mold areas of cooling will be feed throat, MTC, oil and mold. So this is very interesting. See, when you talk of caps and closures project, you can typically see a 12-tier previously running machine was consuming up, it's a two IAMs were connected, Manoharan machines. It is a water-cooled chiller. It was consuming about 11.5 units. So thorough study was taken. Then we replaced that with our 45 kilowatt chiller. So we had a saving of almost 3.5 to 4 units. So this is where it started our journey towards converting existing machines into inverter customers. So similar 9 kilowatt cooling capacity into 2, we have replaced with one chiller of 20 kilowatt. So almost you can see 3.5 units savings. So 1 unit is about 80,000. So 3 units means about 3 lakhs. So hardly about 6 or this 5 TR or something will cost about 20-30% more than the normal chiller. It is not very expensive also. We are able to develop because we make volumes. Japan makes volumes. We are able to mass produce the product. We are able to give a 20-30% of the standard chiller cost. If there is no customization, then the cost is very optimal. So within the difference in cost can be made within 2-3 months can be payback because of the huge power saving. So this blow molding machine, what our customer has replaced, that 15 TR was running for 70 DPH machine from 12 units to 7.6 units. That is their biggest bottle size. This is the saving. If you go for smaller bottle sizes, you still get more savings. So I have taken the worst case scenario here. So this is up to 500 ml bottle and about 40 to 41.5 kg production per hour. Similar DPW machine. So this is the saving. From 21 units, they were able to save around, the difference was about 10 units. 8 to 9 units they were able to save this. So based on that only they have replaced now 8 machines. Out of 12 machines they have replaced 8. Now further they are replacing all the machines. Similarly for thin wall, for one typical customer, for existing from 15 units, our unit power was about 8.6 units. This without the pump inverter itself we were able to save. Suppose if you have an inverter pump and that investment is extra, then again you will have better savings. So this is the saving, plus their chiller was inside the factory which was making lot of noise. Our chiller will be restricted to about 70-75 dB operating noise level. So they were able to get that advantage also. Then PET preform, we have replaced one 19.2 TR with our 17 TR chiller after thorough study on the cycles and units. So they were able to save about 6 units when compared to the model and size. So here the calculation is very interesting. Maybe you have a look at it. It will be available on the website so you can compare this. So you want to make any such calculation for your application specifically to study and suggest. We are doing that typically for most customers who are convinced to go for this. See here we have calculated that an inverter chiller is having better running cost, life cycle cost when compared to even a cooling tower. So that is the calculation. This is for one specific customer we have calculated, and customer replaced 4 of his cooling towers with 4 chillers, inverter chillers. So this is one typical application, 35 kilowatt application. So different applications for induction heating also. In one of our customers' location in Chennai, Super Auto Forge, they were already using a chiller for so many years for one induction specific 250 kilowatt induction heating application. So when we replaced this, we were able to get a savings of about 7 units was the saving. So even by replacing that chiller with a new chiller, they were able to get the payback within 1.5 years. So this is one typical application. Then another typical application is in a textile for RF. For RF dryer, normally the customer recommends radio frequency drying, they suggest a cooling tower. But the cooling tower is again affecting the performance and life of the equipment. So we suggested them. So we have already given one 20 TR. So that we replaced by our inverter model. So there, if you see, we are able to get a savings of about 1.5 lakhs savings even when compared to a cooling tower, considering some water cost. Of course, it again, we cannot, I will not say that the solution is suitable for everybody. Again, depending on the water cost, we can calculate that method. So this is another 60 TR. So conclusion is, the advantage of the inverter cooling is it delivers cooling capacity at very low energy, so the ER ratio is better. Enhanced productivity without any water, zero water, because tomorrow we are going to go to an area without water. So, and you can run the chiller at higher temperature. Smaller genset, so that capital cost can also be an advantage. You can modelize up to 12 units with a master-slave concept, and very high accuracy, 0.5 consistent temperature, 50-degree ambient operation, and by properly sizing the equipment piping, we can save a lot of power on the operational cost of the pump. Thank you.
More cost-saving ideas. I request Mr. Muthukrishnan to present a memento to Mr. Manohar.